What up? It's your boy The Juiced. Welcome to It's Simple, where learning will be made easier. This video has been proudly made possible by Brandon Web and Graphics Designs. Be sure to check them out for all your graphic and web design needs. In this video, we're going to talk about differentiating using differential rules. So the question may come as: determine f first prime of x, or first derivative of f of x, or determine dy over dx, or dx. So number one, we have to know that when differentiating, the first rule about differentiating, a constant becomes zero. So for example, if you're given that f of x is equals to maybe 7, know that f first prime of x, or the first difference or the first derivative of f of x is equals to 0. Why? Because the first rule says that the constant or a constant becomes 0. Then rule number 2, when differentiating, maybe let's say we're given that f of x is equals to ax to the power of n plus maybe b. Okay, so number one, you can notice that our b actually is a constant. So b is going to give us how much? 0. So when we differentiate ax to the power of n, number one, when differentiating, we say f first prime of x is equals to, the power will multiply the coefficient. That is the first thing. So it's going to be a times n, then your x. Then after multiplying the power with the coefficient, you're going to subtract 1 from the power. Then your constant will become what? 0. So what you have to remember is that the power first multiplies with the coefficient, then after multiplying with the coefficient, you subtract 1 from the power. So let's say, for example, we were given that a g of x is equals to 3x squared minus 5. Then we are asked to determine what g first prime of x, which is equals to, then we said number one, we multiply the power with the coefficient, which is going to give us 6x. Then we are going to subtract how much? 1 from the power, which is going to give us 2 minus 1. Then the coefficient becomes what? 0. Then therefore g first prime of x will give us 6x. So remember guys, that when you are asked to multiply an exponent with a coefficient and a power, the power will first multiply the coefficient of the variable, and after multiplying the coefficient, you are going to subtract 1 from the power, and whatever constant you have becomes 0. So that is rule number 2. So let's move on to rule number 3. Rule number 3. What's happening here? Oh, so that happened. Okay. So number 1, a constant becomes 0. Number 2, when multiplying an exponent, you first multiply the power to the coefficient. Then after that, you subtract 1 from the power to get the first derivative of f or dx or whatever you have. Number 3, this one is very, very, very important. It says that when you are given dx into x squared minus 4x plus 2, whenever you start differentiating, you lose this dx, which is going to give us equals to, then this 2 will multiply the coefficient, which is 1. So 2 times 1 will give us 2. Then we subtract 1 from 2, we're going to get x to the power of 1. Then the power of this x will multiply the coefficient, which is 4. So 1 times negative 4 will give us negative 4. Then x, that 1 will subtract. Okay, let's do the subtraction on the original equation. So where is our x? So this one will be subtract 1, which we are going to get what? X to the power of 0. Then a constant becomes what? A constant becomes 0. So our answer basically is 2 to the power of x, then minus, then any number raised to the power of 0 is 1. So it's 4 times 1, which will give us 4. So dx, when you differentiate, you get 2x minus 4. So guys, here the rule is, whenever you are asked to find dx, whenever you start differentiating, you lose the dx. So what would happen if you had to simplify first? Let's say, for example, you have a dx into, then let's say we have 3x squared plus x squared minus x. Okay. Here guys, it's clear that we have like terms, this one and this one. So now that we are simplifying first, we're going to write your dx, then your brackets, then this one plus this one is going to give us 4x squared minus x. Okay, then our brackets. So you only lose the dx whenever you are differentiating. So now that we're differentiating, we're going to lose the dx, where we have equals to, then this 2 will multiply the coefficient, which is 4. 4 times 2 is 8, then x, then this 2 will minus 1, we're going to get 1. So then minus, then this 1 here, the power of x is going to multiply this negative 1 in front, so negative, which is going to give us negative 1, which is x. Then this one will minus 1 to a power of 0. So our answer is going to be 8x minus 1. Yeah, hope you got it, guys. So whenever you are asked to determine dx, you're given something, if you have to simplify first, you do not lose the dx. You only lose the dx when you have, after simplifying, when you are differentiating. So that is rule number 3. Then the rule about dy dx, then it's going to be number 4. Dy. Oh yeah, I made a mistake there. So here, when you're asked to determine dy over dx, when given that, okay, given that y is equals to 3x squared plus 4. So in this case, already our equation is in its simplest form, so there is no need for us to simplify. So we're going to write dy over dx is equals to, then the power multiplies the coefficient, which is 3, we're going to get 6, then x, then 2 minus 1, it's 1, already it's 1 on top, so there is no need for me to write it. Then our coefficient becomes 0, so our answer becomes dy dx is equals to 6. Guys, here you don't lose the dy over dx. So let's say for example, we're given something like 3 y is equals to 3x squared plus 2x squared minus x. So here we're asked to determine y dy over dx. So it's clear that our equation on top here is not what in its simplest form. So number one, we have to simplify it first. So it's going to be y is equals to 3x squared. Wait. Our like terms. So our like terms, it's 3x squared and 2x squared. When we add them, we get 5x squared minus x. So then now that our equation is in its simplest form, we write dy over dx is equals to, then this one times 5 is going to give us how much? 10x. Then 2 minus 1, it's 1. So here it's 1 on top, so it's 1 times negative 1, which is minus x. Then 1 minus 1, which is 0. Therefore dy over dx is equals to, then any number raised to a power of 0 is what? It's 1. So it's going to give us 10x minus 1. So guys, dy dx, you go with it until the answer. The answer has to contain dy dx. It's nothing like dx. Dx, you know, you lose dx whenever you are what? You are differentiating. But here, whenever you start differentiating, you put your dy dx. Nonetheless, when you are simplifying the equation, you don't have to put it because you have not yet determined what dy dx. So yeah, so let's talk about rule number 5. Rule number 5: no root sign. So far we've been doing examples whereby there is no root signs, but whenever you are given an equation that has root signs, you have to simplify it. No, you have to remove the root signs first before you can what? Differentiate. So for example, let's say we are given that g of x is equals to, let's say, root of x minus 3. X minus 3. Root of x, then minus 2x squared plus 2. Let's say we're given something like this. Then we are asked to determine a dy dx, dy over dx. So in this case, number one, we said that there should not be a root sign. We cannot differentiate where there is a root sign. So we're going to simplify our equation first. So g of x is going to be equals to, then we know that when there's a root sign, this in front of the root sign is 2. So this root sign, actually, we can write it as x to a power of, the power of x here is what? It's 1. So it's 1 over the number in front of the root sign, which is 2. Then minus 2x squared plus 2. So now that there is no root signs, we can now differentiate. So we are asked to determine what? Dy over dx, which is equals to, then half, this power is going to multiply the coefficient here. 1 times half, let's say, is what? It's half. So 1 over 2. Then x. Then this half will minus 1. We'll get what? A negative 1 over 2. Then minus. Then this 2 will multiply the coefficient of x, which is 2. We're going to get what? 4. Then minus 1. Then we're going to get x to the power of 1. Then a constant becomes what? 0. So therefore dy over dx is equals to 1 over 2x to the power of negative 1 over 2 minus 4x. Okay, I know mathematicians or people who know maths, you'll argue that we don't leave this like this, because it can also be written as what? Dy over dx which dx is equals to, then is it, I think it's 1, it's 1 over 2 to the power 2 times x to the power of 1 over 2, then minus 4x. We are applying the principle that 1 over 8 is the same as 8 to the power of negative 1. So basically the power here is 1. Whenever we bring this 8 on top, the power becomes what? Negative. But in this case, we're given that x to the power negative 1 over 2 is equal, therefore it should also, so whenever we bring it back to this side, it's going to give us 1 over, then whatever we have here is going to go under, but the power is going to become what? Positive. It's going to be 1 over 2. So when we bring it in front or on top, it becomes what? This. So this is what we applied here. Yeah. So guys, this is basically how you should differentiate. But there is a 6th rule which states that you have to simplify first before you differentiate. But you already picked that up. But let's do it. 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 Okay, number 6. Okay, this one should be the first rule, but simplify first. Okay. So, we have a 7th rule actually. So this is the 6th one. So you simplify first. So let's say, for example, you're given that y is equals to let's say x squared minus 2x plus 1, then all over x minus 1. So guys, you cannot differentiate when you are given what you have something like this. You have to simplify it first, which is something that we already been doing. So in this case, you are asked to find the let's say dy dx, so that we can get the hang of it. We're asked to find dy dx. So number 1, we said before we differentiate, we have to simplify first. So we're going to have y is equals to, then here let's factorize it. Whenever you have something like this, usually you are required to factorize, usually when you have something like this. So it's going to be on top. When we factorize on top, it's 2 brackets, then it's obvious minus and a minus, then here it's x and x, then it's 1 and 1, then we have x minus 1. So this bracket will cancel this one, then we get y is equals to x minus 1. Then we are asked to determine what? Dy over dx, which will equal to, so this one here will multiply there, so we're going to have 1, which is x. Basically we have x, then 1 minus 1, which is 0, then a constant becomes what? 0. Therefore dy over dx will equal to 1. So yeah, so now whenever you have something in like this, of this form, whether you have to factorize or simplify first, whatever works best for you, but you cannot differentiate, which is impossible. You know it's impossible to differentiate without simplifying first. So I think the last but not least, number 7, it says no variable under a fraction line. Yeah, so let's say, for example, given that y is equals to h of x, because I want to determine h plus prime of x. So h of x is equals to 1 over x minus 2 plus 4. Yeah, so this is how it is. Then we are asked to determine h first prime of x, or first derivative of h of x. So what's gonna happen is, number one, the rule says no variable under a fraction line. So a fraction line is this line, here. This is our fraction line. So we have a variable on here. So what's gonna happen is this: the variable is x, right? So it means that we have to remove this x and put it here. So when we simplify h of x, we're going to have 1 over -2. Then when we bring it on top, it means that we're doing the reverse or the inverse of what the x is doing right now there, right here. So now it's dividing 1. So when we bring it here, it's going to multiply the whole thing. So remember, we said whenever you have something like 1 over 8, it's similar to 8 to the power of -1. So here 8 had the power of +1. So when you bring it on top, the power becomes negative. So which means that the power of this x is 1 here. When you bring it on top, it's going to be -1. So plus the 4. So now we're in the position to differentiate. So we're going to have h first prime of x, or first derivative of h of x, which is going to be equal to this power times the whole thing here. We're going to have a positive 1 over 2. Then we have our x. Then here is going to -1. We're going to have -2. Oh no. We made a mistake. Did we make a mistake? I don't know. You guys correct me. This one is for you to correct me. Did we make a mistake here? It's okay, guys. It's okay. It's up to you. You will correct me. Because when we bring it here, it's going to be 2x, not 2 plus x. So I think we made the mistake here. Do I fix it, or do I do another example? It's a lot of work. Do I fix it, or do I do another example? Okay, let me fix it. Okay, I know that it's h of x, then 1 over x minus. It was a lot of work, but okay, what can I do about it? I have to fix it, right? So we were given that h of x is equals to 1 over x minus 2 plus 4. Then we also determine h first prime of x, or first derivative of x. Okay. So yeah. So number one, we said we cannot differentiate whenever there is a variable and a fraction line. So we have to take this variable here and put it on top. So since this variable is going hand in hand with this 2, we're going to take the whole thing and put it on top. And remember that we said 1 over 8, which has the power of +1. Whenever you bring it on top, the side here, it's going to give you 8 to the power of -1. 8 to the power of -1, which if you put it on a calculator, will give you the same value. So here we're going to take this whole thing, x minus 2. So it's going to give us h of x is equals to, then we put the whole thing in brackets, which is x minus 2 to the power -1, then plus 4. Okay, so this -1 is to go in here and go in here. So it's the same bracket, but raised to power of. Okay, so which is going to give us x is equals to, this one and this one is going to be x -1 minus 2 to the power negative 1 and plus 4. Okay, so this is our constant, this is our constant. It's going to become 0 and 0. And we're left with what? We're left with x to the power of negative 1. So therefore, h first prime of x equals 2. This one will multiply here. We get how much? We get negative 1, then x, then it's 1 minus 1, which is negative 2. So basically, h first prime of x, or first derivative of x, is equals to negative x to the power of negative 2, which is also equals to a negative 1 over, then we take this x downwards, it's going to be x to the power of 2. So this is our what? This is our first derivative of h of x. So guys, remember, no variable under a fraction line. Let's say another example, we're given that, let's say we have y is equals to 1 over root of x to the power of 4. Let me write it clearly so that everyone can see. Over root of x to the power of 3. Yeah, so number one, we said no root sign. So the first thing first, we know that in front here it's 2. So therefore, when we simplify, y is equals to 1 over, then it's going to be x, then it's going to be 3 over 2. Then we said no variable under a fraction line, so we have to bring this x on top. So it's going to be y is equals to, then x, because this one is when it's here already, to the power of negative 3 over 2. The power becomes negative, remember, from this thing, from this example, from that fact. So this thing is going to give, so since now we have our what? We have everything sorted, no variable under fraction line and no root sign. We can now differentiate. Oh, what were we asked to determine? We were asked to determine dy over dx. So this power will multiply the coefficient, which is 1. So we're going to have what? Negative 3 over 2x. Then it's going to subtract 1. So let's say 2 over 2 minus 3 is 5 over 2. So it's going to give us negative 5 over 2. So if we bring this x down to 2, we're going to have, oh, remember guys, we're asked to find out dx dy. So in front of here, it has to be dy over dx, which is equals to, then even here, therefore, dy over dx is equals to, then it's negative, which is 3 over 2 to the power x to the power 5 minus 2. So guys, this is how you differentiate using differential rules. So we'll catch you on my next episode. Is it episode? Video. So yeah, that's how it is, guys. And this video was made possible by Brandon Web and Graphics Designs. Be sure to check them out for all your web or branding needs. And they also provide business solutions such as consultations on matters of maybe tax returns and all those things. Just check them out, guys. Check them out and they will tell you what they are all about. So yeah, peace.